Hello everyone, my name is Chris Edwards and today we are going to write a SQL query. Our problem today involves a useful kind of calculation that is a common component of time series analyses and executive level reports. A man named Sisyphus has been trying to roll a boulder up a large hill every day for what feels like forever. Every time he thinks he's getting close to the top of the hill, something inevitably goes wrong, and the boulder ends up rolling all the way back down to the bottom, forcing him to try again the next day. One day, refusing to be discouraged, Sisyphus decides to start tracking his progress, so that he can at least tell if his boulder rolling ability is improving over time. For 2 weeks, every time he loses control of the boulder and it goes rolling back down the hill, Sisyphus records how far up the hill he got that day in a simple database table called rolling data with the following structure. In each row, Sisyphus records the highest point of his ascent on the given attempt date. This raw data is a good start, but as an experienced data practitioner, Sisyphus is wary of the effects that random fluctuations from day to day might have on the overall picture. For example, if he sees that he got farther one day than the day before, does that mean that he is actually getting better at rolling over time? Or did he just have a particularly good day by accident? In order to better see the overall trends in his boulder rolling performance, Sisyphus would like to calculate a rolling average for each date. Specifically, for each date in the data, he wants to see the average height in meters across 3 days, the date itself, the day before, and the day after. We need to write a SQL query that helps Sisyphus get the rolling average that he needs. And just to give a better sense of exactly what we need to calculate here, for people who are less familiar with the concept of a rolling average, let's look at a specific example, the rolling average for the date of March 5th. So I've prepared this kind of sample calculation here. Per the problem statement, we want a rolling average including the day itself, the day before, and the day after. So that means the average across the current date, March 5th, including also the day before, March 4th, and the day after. And so if we look here at what that actually gets us, we get 27.1266 repeating. And if we look over here at our expected output table, you see that is precisely what is expected for the date of March 5th. All right, that is all the setup for today. If you want to have a crack at solving this problem yourself, there are links in the video description to this full problem statement and instructions on how to replicate this coding environment on your local machine. Feel free to pause the video now and come back later for a solution walkthrough coming right up. All right, welcome back everyone. We will now take a look at a possible solution to this problem. Now, I have labeled this as an advanced SQL problem, but not because it is particularly difficult. It's really quite an easy problem if you happen to be familiar with the specific SQL language feature that makes it easy. However, that feature itself is what I would consider advanced SQL functionality, the type of thing you probably won't need to use all that often outside of a few specialized use cases like this one. But before we get to the main trick to solving this problem, let's work our way up to it a little bit by analyzing what the problem is asking of us. We are being asked to find an average of some kind, which may make you think of aggregation, of group by statements. However, there are reasons to be skeptical of going that direction. The rolling average report we are being asked to generate has the exact same grain as the source data. In other words, one row per date. Usually, though not always, you use a group by statement when you want to roll up a finer-grained source dataset into a coarser-grained summary dataset. But here, we aren't changing the grain at all. Instead, we want to calculate an aggregation at the same grain as the original table, incorporating some data from the surrounding rows. And that's another hint: the surrounding rows. Our aggregation depends on combining data from rows that are adjacent to each other in the context of a particular sort order, namely chronological order. The rolling average for each date needs to incorporate the data from the day before and the day after. Put another way, we need to use data from the row before and the row after, assuming the data is sorted in chronological order by attempt date. These two big hints, aggregating without changing the grain and the aggregation being dependent on the order of the rows, point us very strongly toward one thing. We need a window function. Specifically, we need to calculate the average of the height in meters column over a window that is ordered by attempt date. So let's try that real quick. I have a query prepared here that does just that. We're selecting attempt date. We're getting average height in meters over a window that is ordered by attempt date. And there we go. So this is a decent start, but as you can see, our numbers here are not lining up with the expected results here on the left. And that shouldn't surprise us because we still haven't accounted for the most important requirement. Sisyphus wants a rolling average for each date that includes just the current date, the day before, and the day after. Right now, our window function is not respecting that specialized rule. To understand why, we need to introduce the concept of a window frame. The frame is simply the set of rows over which the window function is computed. This frame can be manually specified or it can be implied, and if your SQL writing career looks anything like mine, the vast majority of window functions you write have implicit frame definitions. Generally, there are two main implicit window frames, and which one you get depends on whether or not your window definition has an order by clause. If it does, like our query here, then the window frame stretches from the first row of the current partition up through the current row, based on the order you specify in the order by clause. So, for example, in our query results here, the value currently shown next to the date of March 5th, this 27.574, this is the average height across the first 5 dates by chronological order. In other words, March 1st through March 5th. If your window definition does not have an order by clause, if we just take this out, and now it's just an empty window definition, and we run that, the implicit window frame will be the entirety of the current partition. And if you aren't doing any partitioning, like we're not here, that means the window frame is simply the entire table, which is why here you're seeing we have the same value in every row because every row is using the entire table as its window frame. So if we stick to implicit window frames, our options are fairly limited. But we can also define our own window frame if the default ones don't suit our purposes. In our case, for each row in our output, we want the window frame to extend precisely from one row before through one row after the current row. And there happens to be a straightforward way of expressing that in window frame definition syntax, like so. I've slightly reformatted the query to split the window definition over multiple lines since it was getting very long, but hopefully it's still clear. After our order by clause, we specify the window frame definition as rows between one preceding, the row before, and one following, the row after. This is one of those nice cases where the syntax for doing what we want looks very much like a straightforward description of what we want in plain English. And if we run this, we get precisely the rolling averages listed in our expected output on the left. And as you can see, the rolling averages tell a slightly clearer story than the noisier raw data. Sisyphus starts off around the 27 to 28 meter area, and he seems to climb higher and higher, cresting just above 29 meters before his average falls back down to around where he started. Ah well, maybe next time. All right, well that's it for this video. Thank you all for watching. If you have any further questions about this problem, or if you think of a different approach to the solution that I may not have considered, please let me know in the comments, and be sure to subscribe for more SQL query writing content in the future. Until next time, happy querying!